Okay, so I'm just going to bring over past projects site plan here. This should work. And this works with PDFs or DWGs. I'm just going to go ahead and place this PDF onto the sheet. This will work fine for what we need. We just need something with contours that we can trace. Okay,
Hmm.
so here's a building site, a building area that I'm working from. If you drag and drop any PDF or DWG onto a sheet, one thing you can do is explode it. If it's vector based, it's going to explode into its lines and fills. So here I've got a fill, for example. Here I've got a line. The one thing you want to look for is in a surveyor's drawing, you want to make sure that the nodes of the contours are not super tight together. The way to think about it is that every three nodes on average is going to create a polygon, right?
Hmm.
So if your nodes are all half an inch apart, and I don't know how or why surveyors do this, but I see it, I mean, it's 50-50 whether the surveyor's contours are usable or not. Um, so if they are super, super tight together, unfortunately, the best solution is to either run it through something like Illustrator or Rhino, where you can reduce the number of nodes,
Hmm.
or just trace it back out from scratch. If it was something like this site where it's only a handful of contours, I would just take the spline tool because it's super quick just to say, okay, well, here's my contours, right?
Hmm.
And the reality is like, yeah, there's a little deviation from what the surveyor sent me here, but I mean that's almost nothing, right? And you can kind of readjust it afterwards, but that's close enough to what I need.
Sure.
Um, you also have options here if you grab all of your lines, for example, so that I don't have these segmented lines. You can grab all of your lines and you can go to Edit, um, Reshape, and Unify. And that's going to unify all of your lines into polylines. It might take a few minutes depending on how many lines you have.
Mm.
Um, Hopefully this doesn't take too long here. There we go. So that's going to give you continuous polylines that you can then magic wand trace them out.
Okay, great.
I'm gonna do a couple more cleanups here. There's like some stuff here. I don't need this stuff, for example. So you can clean it up however much you need to here. But then when it comes to applying these polylines to a site mesh, so let's just isolate these down a little bit. I'm gonna grab a handful of these. We'll call that good. I'm just gonna move these, oops, up 200 feet. And then I'm going to draw in my mesh. So for the mesh, obviously make sure you're using the right layer. There might be a favorite for it. And usually what I do is I draw in the mesh to the property lines. In this case, like I don't really see property lines here, other than that one on the south. But I would trace it around carefully to the property lines. Everything within the property gets one mesh, everything beyond the property gets an extra mesh. Because usually closer to your building area, you want to be higher detail. Everything beyond your building area, it kind of needs to be a close approximation. So once you
Hmm.
get it drawn to your property lines, we'll move it up here 200 feet so we're overlapping, right? So here this would be, I don't know, something like that. Get it close. Okay, so now I want to apply these contours to my mesh. If the contours are all usable and there's no nodes that are like super close, there's no areas where they're overlapping, like this could potentially be a problem area right here.
Mm.
Probably not, as long as they're not overlapping and nodes aren't too tight together. You could do a little bit of preventative maintenance on that, checking where there are super close nodes. If we can clean some of that up, it's going to be better. But I want to apply these to that mesh, and I try to be as systematic as possible. So complete one task before I go on to the next. So I've evaluated my contours, I've cleaned them all up and or redrawn them as needed. They're ready to go to the mesh. Now I'm going to apply them to the mesh as one systematic sweep. This is I call it one of the least intuitive tools or one of the unintuitive tools in ArchiCAD because there's no like magic apply contours to mesh option. There's a sort of step-by-step process. You have to select the mesh. You select the mesh tool from the toolbox and you make sure that the geometry match method in the info box is set to polygon. Once those three criteria in that order are met, you can hold down the space bar to activate the magic wand, and then you can just space bar and click on each contour.
Okay. Can you
Um,
show that one more time? I don't know if I saw where you were verifying those
yeah,
settings.
so I select the mesh just actively in the floor plan.
Hmm.
Over here in the toolbox, I select the mesh tool.
Hmm.
And then up here at the top, I make sure that the geometry method in the info box is set to polygon.
Okay, got it.
And then just hold down space and click. And again, being systematic, I'm going to apply all of these contours all in one sweep. Now, let's just say, for example, I had a relatively flat site with maybe only 10 or 15 contours.
Hmm.
And if they're relatively simple, you can technically, same criteria, select the mesh tool, and polygon method, and you can literally just click directly onto the site mesh and start applying contours. You do have to click inbound from the mesh edge. Um, so if I go to, let me get this one done right here, right? So I want that to run to the edge. If I were to start on the edge, it activates the pet palette. So you
I
can't
see.
start placing a contour by clicking on the edge, but you can start by clicking inbound from the edge. And this is a workflow that I found only just recently that works so that you can do this sort of in rapid succession. So I could take this contour and run it to the edge and then run it back in and then
Oh,
do the next contour as all part because it's running past the mesh, so it can't add contour nodes. So it's
uh-huh.
actually going to create these as separate contours,
Right.
right? So we'll just go to track this through and then come back up, right? And it's going to add those contours.
I
The
see.
fastest way, as long as you don't have to worry about how many nodes are in that contour, is just to hold space and click.
Hmm.
Um, so I apply all the contours throughout the whole mesh before I've elevated anything. Now, if I look at this and say, here's my mesh, we could see in 3D, right, it's still a flat plane.
Hmm.
Doesn't have any contour elevations. So now we want to go systematically and elevate these contours up. And one thing I recommend doing, because sometimes, especially when you get areas like this where there are contours really, nodes really close together,
Hmm.
sometimes it's hard to isolate those areas out or pick those out from the rest of the model. So I recommend elevating every 5 or 6 contours and check in 3D so that there are no glitches or errors. I spent, and this is lesson learned the hard way. I'm going to give you this lesson ahead of time. I
Hmm.
spent like the better part of 6 hours working on a site mesh, pulled it up in 3D, and there was no mesh there. You could select it, you could hit F4 and hit Command A, and it would show that there were nodes and contours and edges that would highlight, but you couldn't see the thing in 3D because somewhere some contours got twisted around each other. And on a site that was like 250, 300 acres with thousands and thousands of contours, it was really hard to figure out where those were at.
I
In
see.
the end, I had ultimately just had to throw the whole thing out and redo the 6 hours work again.
Oh, wow.
So, lesson learned, even on a small site, like elevate 5 or 6 contours, check it in 3D. Go back to 2D, elevate 3 or 4 or 5 contours, check it in 3D.
Sure.
That one 15-second check will save you hours of headache trying to reverse what you had done.
Hmm.
So, okay, so we're ready to elevate these contours. One thing that I recommend doing is, so this is 280, 276. Let's actually grab these ones and pull those over as well. Um, right, so this one right here. That up there is my 280 contour. One thing that I do usually do is I don't, for the most part, place these true to their elevation because there's too many times where the elevations aren't necessarily just a couple hundred feet above sea level. They might be thousands of feet above sea level.
Hmm.
And I don't want this site mesh to be, thinking about a project in Denver or Aspen. I don't want it to be 4 or 5 thousand feet thick. I want it to
Hmm.
be like start off at 2 feet and work my way up.
Sure.
In the case of this project in particular, this is on the Puget Sound. Um, so I know it's 280 feet above sea level, but as part of this extended site model, I actually ran it all the way down to the beachfront where it meets up. So I did want this to be true to height so that
Mm,
I can include those lower contours beyond the property line.
I see.
But for the most part, I would typically say like this isn't 280. I would say maybe this is 80 feet and work my way up from there.
Hmm.
So now I want to start elevating these contours. To do that, and again, this is not necessarily intuitive. There are multiple ways that you can do it, but in my mind, the best way to do this is to select the mesh, and then if I click on a node on a contour, notice it isolates that contour out. That's its own contour now. So when I click on it again to activate the pet palette, the only thing I'm editing or applying this to is this one contour. So I'm going to click on the Z value right here. I'm going to say apply to all and I'm going to make this 278. Or if I was like reducing down the total height, I would say it's maybe 8 or 78 or something like that.
Mm-hmm.
Whatever makes sense. You kind of have to play it by project needs. But in this case, I'm going to say that this is 278. Say OK. I know that this one is also 278. And I'm just going to kind of systematically go through the process of bumping these contours up.
So
Um,
what are you clicking again?
so
You
I'm
click
clicking
on,
on the contour to isolate
uh-huh.
it.
Yeah.
I'm clicking on the contour again to activate the pet palette.
Mm-hmm.
It's this Z axis on the pet palette that I'm working with.
Okay, got it.
So this one's going to be 84. It is critical to set apply to all. You could technically, if you've already pre-established your project zero, you could say I want it this high above project zero. But I want
Mm-hmm.
to show you exactly how I deal with that in just a second, because normally project zero is, or sea level and project zero are based on your building position, and we don't
Mm-hmm.
have a building yet. So this is just establishing the site. So we say that that's 84. Let me get through a few more of these here. 86, 88. And you can see like doing this systematically, you kind of get into a rhythm,
Mm-hmm.
and it's really easy to kind of fall into that rhythm and get a whole site done and realize you're kind of hosed because there's some error.
Mm-hmm.
Oh, I clicked the wrong thing there. Want to get through building site here. Okay, so that's probably good enough. And then let's check that in 3D. Oh, it looks like so one of these contours I did not put at the 200 set, or I put it, yeah, 100 feet too high or 200 feet too high. And that's another thing is like you can fine tune this directly in 3D, the same as I was doing a floor plan. So I can isolate this contour out. Notice there are no other contours here. And I
Mm-hmm.
can either drag that down or I can elevate negative 200 feet.
Oh, okay.
And there's always going to be like some points along the edges where you're going to have to like sort of massage this up. Usually when you're at the property corners, unless the surveyor's giving you like property pin heights, which some surveys will sometimes have that, and you
Mm-hmm.
can elevate those corners to the exact height. But for the most part, you're not usually building right up against a property corner. So, like massaging it up to what looks good is usually close enough.
Uh-huh.
Um, you can also do this directly in 3D. So I can select this contour and drag it up, align with that one. I see that that's 104, so I can say that this is 106. This is going to be 108. You can also use the elevate, make that 110. So you can use a combination of these different sort of features to get the site to where it needs to be.
Mm-hmm.
Okay. And you can see, and the nice thing about doing it in 3D is you can see right away, like this contour and this contour are flush with each other. So this is probably a foot too low or 2 feet too low.
Right.
So now I need to go back through and readjust this. But then you also want to go back in 2D and make sure that that's at the right elevation, right? So then in 2D, I might need to come back and be like, oh, what contour elevation did that say it was at? If it was really supposed to be 106 and this was 106, then I do have a flat spot through there. So
Mm-hmm.
some combination of like what's shown in 2D, what's shown in 3D, make it look right in 3D, verifying 2D kind of process.
Mm-hmm.
Okay. Um, let's see, other things about the site that are useful here. So next thing is once I get my site modeled, I want to know relative to my building area. So if I've masked out my building and I say that this footprint of my building is at 0 to project 0, but I know that that needs to be at, let's say the finished floor is going to be at this level right here. Let's say it's 110, for example.
Mm-hmm.
I know that like from here to here needs to be flat, or maybe it's like 110 point something. So the way that I usually do that is by drawing a section through the building to that contour, right? So I know that that contour is at 110. So if I were to open this section and pull it down, so the right edge of that contour, 110, needs to be at my finished floor level. I can pull that to right there.
I see.
And now my finished floor is at 110.
Mm-hmm.
The next step as part of that, though, is to go to options and project location. And here I'm going to say my altitude, my sea level is 110. And
Mm-hmm.
all this is doing is it's equating how far above sea level is your project zero. It doesn't
Mm-hmm.
change anything in the model, But what it does do is it says that this thing right here should be 110 feet above sea level. Where does that come up with 360? Oh, I think that yeah, this is in meters. There we go. Now it's 110 feet above sea level.
Gotcha.
Um, so another cool thing about this is like let's just oh, first of all, let's take this mesh. I want to get rid of all of that triangulation because that's super messy. And so we're going to say user defined ridges right here. So that's going to
Hmm.
eliminate all the triangulation. I like the triangulation as I'm drawing a mesh because it shows where contours aren't flush with each other, right? If
Sure.
one's above the other, it has to triangulate. So I can see
Hmm.
what contours I've done and what I still have left to do. We can turn off the cover fill or we can make the cover fill white. So now I have this mesh. Let's just, as a for instance, say that the surveyor has given me location of a site wall here. Maybe it's a big, thick, chunky site wall. And I want to draw that curvy site wall. One of the best tools for that is actually the mesh tool. So if I move this up, we'll say 75 feet, I'm going to put a mesh in here and then drag it back down 75 feet. So here's a site wall. Here, let's just see. This contour is, what's the elevation of this contour? Oh, is 108. So if the surveyor said that this is I don't know 110.25 feet, I can select this mesh and say that this height above sea level is 110.25 feet, right? And it's going to elevate that point to sea level. So that if
Hmm.
I were to look at these things together now, there's that site wall piece punching through.
Hmm.
And we just say want this to be something like, I don't know, just make it something that stands out there. Um, so you can go through and actually elevate the points of that as they've been given by the surveyor. So surveyor might say that this is 109.5 or whatever it is.
Hmm.
And I'm just
And
adjusting these.
and if it was like a straight wall, like the top of it was not sloping, then you would just click that apply to all, right?
Yeah,
Okay.
exactly. Or if it's a straight wall, and maybe it's not even the mesh that needs to be used. Maybe it's something like a slab.
Hmm.
So, right, these tools, rather than thinking about them by their name, think
Hmm.
about like what geometries they can form. So if it's literally just a wall that has a flat top all at the same elevation, the wall
Hmm.
tool could even do that. You could,
Hmm.
you could draw a wall that had that serpentine shape, or maybe
Right.
it's straight. Or if you have like say a site fence that needs to carry down the site, the railing tool is great for that. So in the railing tool, there might be favorites talking about like timber fences, right? So it's not just about railings, it's about like what shapes can I generate with this.
Hmm.
So I've got like these pickets and these rails and these main posts and all of this stuff that you can redefine, or you could even have panels, or I've used it for like chain link fences with like a panel as the
Hmm.
chain link part. And the cool thing about that is if I need to like wind this down the site, it can snap to all of the various elevations and link that up and
Right.
have a fence that goes down the site and maintains its looks like I maybe clicked on some wrong points. Anyway, you get the idea.
I
It
do,
should be
yeah.
able to flow with the site. Yeah, I wasn't clicking on attaching it to the site. So you have to wait for it to highlight to the site. I don't know why. I thought I turned if you say in 3D, I want it to be smooth. Um, if I say all ridges smooth, that'll give you a lot softer.
I see. Okay.
Yeah. Anyway, so different tools for different things there. If I have let's say like a daylight basement or something that's sitting down here. Best thing to do there is your building becomes the operator. So under design and solid element operations, this becomes my operator. This becomes my target. Subtract with upward extrusion and execute. And that way, if and when my building changes position, um, it
Wow.
automatically maintains that trimming.
So wait, show that one more time. How does it like, how is it so smart that it just does the upward extrusion without an actual form there?
So the operator is the form. It is the trimming body for the extrusion. So under design and solid element operations, um, I want the trimming body, the piece that I'm
Uh-huh.
trimming to be the operator. The mesh is what I need to be trimmed. So that's going to be the target. And then the operation that I'm going to do is upward extrusion. So
Oh,
everything
okay.
above the operator gets cropped out.
Okay. Yeah, it's just like a roof and a wall or something like
Yep,
that.
exactly.
Okay.
Exactly
All
like
right.
that. Now there are some cool things that you can do with this to like, I don't necessarily, let's say I have a driveway, as another for instance. So if I have a driveway that comes around something like this, right,
Mm-hmm.
across my site, and I'm going to say that this driveway is um, sort of 12 feet wide. I don't necessarily want to have a separate mesh that I'm trying to like match into um, match into my main site mesh because there's always going to be cases where it doesn't quite line up or it doesn't feather out. Maybe I do need it to be a separate mesh in order to like show retainage or build up or exact slope. But if I just want it to follow the slope, and this works for driveways, it works for paths, it works for if you want to show differences from like maybe a lawn or a an area that has like bark chips or something like that. You want to
Mm-hmm.
differentiate parts of the mesh to be different, but not have to splice together a whole bunch of meshes. So I'm going to move this over 150 feet. I'm going to grab a slab and magic wand that slab. Move this back 150 feet. Now let's take a look at this in 3D. So here's this slab. Oh, I see what's going on here. So, well, first I'm going to take this slab and we'll say that this slab is, sure, we'll say concrete. Let me give it something dark and we'll make it 30 feet thick to start with. The most important thing here is that the slab extends into the mesh at the lowest point and extends above the mesh at the highest point. So like if my
Mm-hmm.
highest point of the mesh is here, I need it to protrude through the slab, but also extend down into the slab. So that kind of makes
Mm.
sense. So there's like a full overlap and extension above.
Okay.
And now I want the mesh to look like this surface for that path. So first thing I'm going to do is I'm going to say that the slab is my target and the mesh is my operator. And my operation is going to be an intersection. I'm going to find where those two things
Oh,
completely
right.
overlap.
That makes
Um,
sense.
and I'm going to say, okay. And now
Uh-huh.
that slab is going to follow that mesh.
Okay.
Now,
Got
I
it.
get this weird flicker because their top surfaces are in the same space. So I
Mm-hmm.
need to alleviate that part. So I'm going to say next, the slab is my operator. The mesh is my target, and I'm going to do a subtraction or subtraction with upward extrusion. And that
Okay.
gives the
Got it.
slab a priority.
Got it.
So having this recording, you might need to scrub back through and kind of go through that step by step, but it's two-part operation. So first, the surface you want is the target. The mesh is the operator. Your first operation is an intersection.
Mm-hmm.
Follow that up with the inverse. The slab becomes the operator, the
Right.
mesh becomes the target, and your subtraction is the operation.
Right. It's exactly like Boolean operations and Rhino or
Yep,
something like that.
yep, just an extra step involved.
Right. So then right now the driveway is like going to that daylight basement. What
Mhm.
if it wanted to actually go to the level that's above it? Like it kind of is built up at a certain point in the terrain and it's arriving at that upper level.
Yeah, so to do that, let's say it like springs off of this contour right here and goes up to that level. To do that, I would actually split it. So use your split command.
Uh-huh.
And so we're going to follow the contour to this point. Now I'm going to take this piece right here. Since this is a slab, it's probably not going to play nicely. Like if we look here, um, right, that piece goes right there. And technically we could pull that down to right there,
Uh-huh.
right? And that happens to actually line up. Um, but if I needed to have any other slope, I could not do that with a slab. So I would have to replace that slab with a mesh so that I could actually like feather this
Uh-huh.
this node to wherever it needs to go.
I see. How did you replace that slab with the mesh just now?
So all I did was I drop this mesh
Oh,
to
okay.
activate the mesh tool, and then I hold space and magic wand that slab. Now if I
Got
delete
it.
that slab, now I have a mesh.
Got
I
it.
would have to come back in here and say that this is going to be that same concrete surface or whatever to match. All right.
Got it.
Now you could do some like other cool things, like if I wanted a curb or something along this edge, you can grab your offset all command right here.
Mm-hmm.
Offset all edges out. If you hit the option key, I've kind of glazed over this a couple of times, but
Mm-hmm.
if I'm offsetting all edges and I hit the option key, it gives me a little plus symbol on my cursor. So I could say I want a 12-inch curb outside of this. So that's going to add a mesh to the outside, 1 foot bigger than the inner mesh. I can then activate the pet palette again and subtract out this inner area, hold down space to magic wand. And now I get a mesh that has like a donut ring around and a
Mm-hmm.
mesh that's inner. So if I take this outer mesh and elevate it up 2 feet, 1 foot, whatever,
Uh-huh.
then I get that curb.
I see.
I can, keep kind of tinkering away with it. Obviously, I don't need a curb that comes there, so we'll pull that part out. Don't need a curb here. We'll pull that part out. And like decided I was going to add a node there. I can use the split command and split to that point right there, right? So I can get that curb around that driveway.
Uh-huh. Very nice.
And that's the same sort of method, even if this was like, say, a sidewalk and a curb cut,
Mm-hmm.
same kind of method I would use for sort of a more residential location. And then after that, you can actually take the individual nodes of that curb, oops, and say that this is going to be my curb cut, right? And kind of massage those down if this were an actual sidewalk piece.
Mm-hmm.
There's a lot of nodes here, so it's not wanting to play ball with me, but you get hopefully get the idea. Like that's essentially how I would like do an actual curb cut. If this were a street curb, an extruded curb along a road, I would then
Mm-hmm.
like use that to actually buffer up to maybe a planting strip or a sidewalk or something
Sure.
for those curb cuts or those walkway cuts.
Great.
Okay. Um, So that's a whole handful of site modeling tips thrown at you right there. There's a lot more to it. A lot goes into site most of the time, in terms of like where the patios, the hardscape, the landscape, pathways, driveways. There's so many different factors, walkways and stuff, steps, site stairs that get put into there. But hopefully this gives you a few tools in your kit to pull from.
Yeah, for sure. I think this is great. Very helpful.
Okay, let's take a look at foundations now. I'm going to show you kind of my preferred method for foundations. And this we'll just use the same piece right here. Like maybe there's like part crawl space, part basement.
Mm-hmm.
Like maybe this actually goes to here, and we have a crawl space piece that sits right here, kind of a condition, right?
Mm-hmm.
So let's take a look at that and how we might model like a footing step here and retaining wall and all of that in kind of one systematic foundation that might step up a site.
Perfect.
Talking about like stem walls, retaining walls, all of that stuff. So here I've got my site stuff. I'm gonna go here and say home story and 1 story down. We're just gonna model the foundation on the floor below. Oh, we have to add a floor below. Okay, let's go in here. So that's that slab. Okay, so this is my crawl space slab. So let's just go ahead and put in some foundation walls here. So for this, actually, generally, I would want to, there's no foundation walls in this. This is just the out of the box template. So there's nothing that I need in here. But generally speaking, I would want like an 8-inch concrete stem wall or a 10-inch concrete stem wall as a composite so that I get global control over my stem wall thicknesses. so that I don't
Hmm.
have to go through and pick out all of my 8-inch walls and make them 10-inch when I need to change them.
Hmm.
Or a lot of the projects I work on might go from like an 8-inch wall, but then the engineer says, well, it's only one story, let's drop that to 6 inches. Save ourselves a few $1,000s to avoid being able to do remodels in the future.
Hmm.
So that happens all the time. So I want to go globally and say that's no longer an 8-inch wall, it's a 6-inch wall. So composites are great for that, but for the sake of what we're working with here, I'm just going to say that we have um, an 8-inch concrete wall. We'll say that the height of that wall is not linked. Oh, not linked. And we'll say that we'll start with a 4-foot wall just because I'm not necessarily worried about where it's at right now. I'm just going to draw these in. So first, we'll draw the wall in around the building, something like this. And if we isolate that out in 3D, I can see these walls sit here. So those walls maybe sit to there. These walls sit here. And maybe this wall extends up between both, something
Hmm.
like that.
Hmm.
Okay. I'm going to make sure that these show story only and symbolic cut. And that's going to ensure that no matter what their height is, they show cut through in my floor plan.
Hmm.
If I wanted these to show overhead, I could change their settings to say outlines only, right? So those are going to be overhead, those aren't going to be cut through, or vice versa. Maybe these are the ones cut through, those ones aren't. Either
Right.
way, it works the same. Now I'm going to go to my slab here, and same thing. We're going to say that this is concrete. Maybe this is a 10-inch footing. Not worried about the elevation of this thing just yet. Um, I would put it on the footing layer if there is one. Again, this is not my template, not your template, so I'm not sure what's going on there. But I'm going to draw this into the perimeter of the building and select that piece. And then we'll just go ahead and say offset all and pull that out 8 inches. And just like we did with that curb, I'm going to do the same thing here, where this is going to be a 2-foot strip footing. So I'm going to offset all edges and hit the option key to offset a copy in 2 feet. And
Hmm.
that just gives me something to trace that cropping with. So now if I hit the pet palette again and subtract this out, right? Now I have that area that I can delete, and that was just a tracing piece to know that this footing is 2 feet wide. Let's go ahead and look at this in 3D, and we'll get this slab in the right position underneath these stem walls. I want to then use my split command to split this at that wall and pull this other footing down below that piece.
Hmm.
Now, this is only part of the story. Obviously, I still need to have a footing under this piece, and I need to connect that footing to that footing. So let's go ahead and draw that in right now. Let's use the plus option, and I'm going to actually use this rotate option right here. Even though I don't have a rotated slab, I'm going to add a slab with the rotated slab. What that allows me to do is draw the first vector along this edge and pull this vector out 18 inches. And then I can grab this edge and pull that edge in 6 inches so that I get that same continuous 2-foot
Mm.
strip footing here.
Okay. I
Okay.
kind of I understood what you were trying to do, but I didn't understand the steps and the tools that you use
Well,
to
let
do
me go
that.
back and start over. So first thing, activating the pet palette and hitting the plus option,
Yeah.
making sure that in the info box, I have this little rotated command, right? Because I want to define the edge that I want to extrude and then
Uh-huh.
how far I'm extruding it. So
Where's the rotating? Where are you showing that?
So the basic geometry methods are polygon, rectangular, or rotated rectangular.
Okay. Okay.
So I'm choosing the rotated rectangular, not because I have some random angle, but
Uh-huh.
because I have a specific distance I want to extrude that to. And I don't want to
Okay.
just click, click, click to define all 4 nodes. So I'm going to use that method so that I could say I'm going to extrude from this point to this point along that vector. And then the third click is going to give me that distance of 18 inches. And
Huh.
I made it 18 inches so that from the inside face of this wall out is 18 inches.
Hmm.
And then I can come back and pull this back another 6 inches to make the full footing depth 24.
Sure, that makes sense.
Okay. And then maybe these ones actually need to be um, pulled back to the inside face of the wall, right? They don't need to run through that wall. So
Hmm.
this is the sort of like fine tuning when you know what the design is, or you've worked with the engineer to work out all these details, you can kind of get to this level of detail.
Hmm.
Now I want to connect this footing to this footing. To do that, I'm going to draw in a new footing. And I'm going to say that this footing is, I don't know, 3 feet. Let's make it a little bit deeper, 5 feet. And I'm going to stretch this down. This is a little guess and check kind of work. But I put in a block here. But I
Hmm.
usually want that to be like, I don't know, like in a 70-degree angle or 60-degree angle, whatever the soil bearing can afford.
Hmm.
So on that, I'm going to select this vector of that slab. I'm going to grab this option on the pet palette and say that this is, I'm going to say it's a 75-degree angle to start with.
Mm.
Okay. And from here, I could see that that node to that point is 2'3" and some change. And just in the interest of being close enough, I'm going to pull that back 2'3".
Mm.
You know, you can be super precise. I could pull it back the extra, whatever, 3/16 it was.
Hmm.
Um, and that, but it doesn't really get me any more detail, although it looks like I'm still off by a little bit there. 1/4 inch. So maybe I just punched in the wrong number. Um, but for any foundation axon, right, this is going to get me the foundation axon that you're going to need to see on the job site to understand where those footing steps need to work with the site,
Hmm.
right? So here you can go, if this is part of my documentation, here I could take all of my footings and go to document, document tools, 3D document, foundation axon, and then I can even annotate and dimension directly into here. So I could say I've got that footing drop. And this
Hmm.
is in meters because it's a weird international template.
Hmm.
Um, it's the US version of ArchiCAD, but they gave us the international template.
Hmm.
And one of the cool things about it is like, let's say that the engineer comes back and says, we need a 6x6 pad footing. We've got a huge point load coming down on this point. So I can take another slab, figure out where that needs to sit exactly. I'm just using this as like a kind of base point. And then I'm going to take this footing and trace it with that plus option on the pet palette. And then I can delete that original 6x6 pad. And then I know that I've got that slab. And if I come back into my, oh, not there, if we come back into the 3D document, it's going to add that in here automatically.
Wow. Can you go ahead and show that how you drew that slab again? And like how
Yeah,
you connected it with the footing and everything?
yeah, so let's say I've got a so that's a 2x2. Let's just say it's a 4x4 on this corner. So I'm going to start by drawing in just a separate slab. So I'm going to say this is X 4 feet, Y 4 feet, right? I don't even care where it's at. I'm just going to get it in here and line it up. If I know it's going to be centered, I know that I need to be whatever 1 foot 5-ish inches there to get it centered on that point. But
Hmm.
it's going to be the same dimensions as this slab. So I'm going to click the plus option and I'm going to trace it out. And then I can delete the original slab that I used to trace it out.
Hmm. I
Now,
see.
if that pad footing, so my typical footing is 10 inches thick. If that pad footing needed to be 12 inches thick, it would have to be its own separate slab. It couldn't be part, you can't have a slab that's 8 inches or 10 inches and then it thickens up to be a different thickness. They have to be kind of pieced together with separate slabs. Um, there are people who will argue that like complex profile walls or beams are a better way to do foundations. And I'm not necessarily refuting that. I don't disagree with that. If you prefer to use beams for your footings, that's fine. I know it works really well for a lot of people. In my mind, I would rather have fewer elements, getting the same level of detail with fewer elements, and the slab tool really is the tool to do that in my mind.
Mm-hmm.
So, and the other thing is like if you use beams or walls, they like to try to intersect with other beams and walls, as opposed to the slab, which is it's going to interact based on building materials, but it's not going to like throw your wall junctions off.
Okay, got it. Good to know. Excellent. This is super helpful.
Cool.
great.
Um, the other thing is, bear in mind that this, just because I have, that site cut out by my main floor, if I open this back up, it's not necessarily going to play nice with these walls, right? Because the mesh and the slabs and the walls don't automatically interact by building materials. So you'll still need to grab your walls and your slabs and set those as operators, set your mesh as a target, and a basic extrusion or subtraction. You don't want any extrusion. You just want to be able to see that building material.
Okay,
Okay. But this is going to be your main target, so that's going to be carving that out. This is just so that in section you can see those building materials.
I see. Okay. So, I know we're kind of close on time, but what if you had like a concrete stem wall and then a wood framed wall above the concrete stem wall?
Yeah, it would be just an extra wall on top. So it would just be this would become your wood stem wall. So this would be let's see here. Oh, that's not what I wanted. I want to go here. I don't know what this template includes or doesn't include. Doesn't look like it shows a whole lot of useful things. Um, but that would just be an extra stem wall or an extra wall on top of it. So if this, for example, let's just do that here. So if this was only retaining here, and I
Hmm.
had a pony wall that sat on top of it, it would just be that.
I see. And
Okay.
then what does it look like on the floor plan?
Mhm. So it could look any number of ways that we needed to show it. So this is going to show as the wall here. I could
Mhm.
set this wall to show as outlines only, so that it shows as like a stem wall behind or a wall behind, and then this shows as the pony wall above.
I see.
Um, it looks like it's intersecting weird here with this wall, but if I go into the settings of this wall, I can probably bump that down, pull this into here, make sure that that's discontinuous. So,
Got
yeah,
it.
I've done this. I actually have. I don't have it open. I have a project down in Ashland, Oregon, Southern Oregon, where there's like sort of this built-up basement thing where there's several layers of 4 foot stem wall or 2 foot. I think they're 4 foot retaining walls because that's the shortest, the tallest they can be without having a structural engineer involved.
Hmm.
So we're like maximizing that out, but we are terracing essentially the crawl space down the site. And it's exactly this condition where we've got a pony wall sitting on top of a concrete wall.
Hmm. Got it. All right, very cool. So what I would like to do next is can you post this to the BIM manual? And then
Mhm.
I think that the roof recording that we did a couple weeks ago also still needs to be on there.
Okay.
So if you could put both of those on, and then I think if you could go ahead and do a write-up for building foundations and roofs within the manual, I think that would be great.
Yeah, and I think it'll be pretty simple boilerplate, like step one, step two, step three,
Hmm.
kind of stuff for most recommended method for foundation. It's foundations are one of those things, like I said, where there's a whole host of different ways to manage them, to model them. I just think that this is, in my mind, one of the best ways to do it.
Okay, great. Sounds good.
So,
And then if in the BIM manual, could you have like a separate section that is like roundtable recordings? And then if like one of our recordings is applicable to the roof sections, you could like duplicate that video in that section as well, or somehow
or maybe
reference
just
it.
provide a link from that to the roundtable recording.
Yes, that would
Yeah.
be good.
I will do that. I'll get
Okay.
that all written up for you. Let's see, I've got meetings through the day today, but I think I can do it tonight or tomorrow morning and get it to you definitely before the end of the week, probably before the end of the day tomorrow.
Okay, that sounds good.
Awesome. Thanks, Marco.
All right, thanks, Patrick. I'll see you next week.
Bye.
Bye.